Kia ora everyone and welcome back to the IA Max channel. I'm Al-Muhi here. In my previous video I talked about Azure VNet, the building blocks of Azure networking. In this video I'll talk about Azure VNet peering, what it is and when to use it. So let's dive in. To understand what Azure VNet peering is, we need to have a recap of how the Azure virtual networking works and when does it make sense to use VNet peering. A VNet is a logical boundary. So resources inside of a VNet will be able to talk to each other. For example, VM1 and VM2 in VNet1 will be able to talk to each other directly, even though they are in different subnets because they are part of VNet1. And resources in VNet2, VM3, and VM4 will also be able to talk to each other again because they are part of the same VNet, even though they are part of different subnets. To enable our resources in different VNets to talk directly to each other, we need to explicitly configure some sort of routing to allow those resources to talk to each other. This is where VNet peering comes in. VNet peering is the simplest method to enable us to connect two VNets together to appear as if they were one VNet. So resources inside those two VNets will be able to talk to each other directly as if they were part of one VNet. One thing to put in mind, if you want to peer two VNets, you need to make sure that they are not using overlapping IP address space. So in the first case, we see that both VNets are using the same address space, so we can't peer those. But in the second case, we see the VNets are using different IP address spaces or non-overlapping IP address spaces, so we can peer those. The other thing to put in mind is that the VNet peering is reciprocal. So if you configure VNet peering on one virtual network, you need to configure the VNet peering on the other one so that the connection could be established. One other thing that I want to mention here is that VNet peering is non-transitive, which means is that when VNet-A peers with VNet-B, VNet-A will be able to communicate with VNet-B. When VNet-B peers with VNet-C, VNet-B will be able to communicate with VNet-C. But that does not mean that in the end VNet-A will be able to talk to VNet-C because the VNet peering is non-transitive. To enable VNet-A to talk to VNet-C, you have to explicitly configure peering between VNet-A and VNet-C. There are two types of VNet peering. A regional VNet peering if both VNets are in the same region, as in the case of VNet2 and VNet3 being in the Australian region, and a global VNet peering if the VNets are in different regions, as in the case of VNet1 to VNet2, VNet1 being in Singapore and VNet2 is in Australia. So what are the VNet peering benefits, or where does it make sense to use VNet peering? VNet peering traffic does not leave Microsoft backbone even if they are in different regions. So even for the case of VNet1 being in Singapore and VNet2 is in Australia, when you send traffic between those VNets, it's still going through Microsoft backbone, which means your traffic is private and it's not going to go over the internet. So you don't need to use public IP addresses and you don't need to worry about encrypting your traffic. The other use case is that if you want to have a low latency between resources in your different VNets and you don't want to worry about bandwidth requirement, so you would use VNet peering because the Microsoft backbone is highly optimized to provide you with a low latency and not having to worry about bandwidth requirement. And finally, VNet peering is not going to cause a disruption to resources you have in different VNets. So when you peer those VNets, this is not going to cause a downtime to the resources in those VNets. They will start to talk directly to each other. Now that we are ready, let's jump in on the Azure portal to see how to configure VNet peering. So now that we are on Azure portal, let's talk a little bit about our scenario here. So let's go to the virtual networks. And in here, we've got three VNets, VNet-A and B and C. So what I'll do, I'll peer VNet-A to VNet-B, and then I'll peer VNet-B to VNet-C. And we also have three virtual machines. So we've got VM1, which is in VNet-A, VM2 is in VNet-B, and then VM3 is in VNet-C. So after I finish the peering, what'll happen is that VM1 will be able to talk to VM2, VM2 will be able to talk to VM3, but VM1 will not be able to talk to VM3 because the VNet of VM1, which is VNet-A, and the VNet of VM3, which is VNet-C, are not paired to each other. To create a VNet peering, let's go back to the virtual networks. Let's click on VNet-A. And under the setting, let's click on the peering tab. To add a new peering, let's click on the plus add button. This will open up the add peering blade. one thing to mention here is that this configuration is actually two pieces. So if you could see here, it is saying this virtual network, this is the first piece, and then the remote virtual network. So what we are doing here, we need to make sure that both VNets are actually configured to peer to each other for the VNet peering to be established. So this configuration is doing both sides. So the first thing we want to do is to give this VNet peering a name. So we'll call it VNet-A to VNet-B. Next, it is asking us, do we want to allow traffic to the remote network, which we do, so we'll leave it to allowed. After that, it is saying traffic forwarded from a virtual network. This is saying is that if the remote network, which is VNet-B, is sending us traffic that is not originating in VNet-B, do you want to allow it or not? In this case, we will block it. In a future video, I'll talk about when is this useful, what scenario would this become useful. Next, it is asking us for a virtual network gateway or a route server. Again, this is outside the scope of this video. We don't want it for VNet peering, so we'll just leave it to none. The next step needs a little bit attention. So as you can see here, it's now saying remote virtual network. So the information that you put in here is regarding the other virtual network. It is as if you are configuring VNet peering for both VNets at the same time from one blade. So we first said VNet-A to VNet-B. What we'll do now is that we'll say VNet-B to VNet-A for the other way around. And now, what is the networking model you want to use? Just leave it to resource group. And this is what subscription ID for the remote virtual network. So we'll just leave it to the current one. And then you want to pick the virtual network that you want to peer with. In our case, VNet-A, we wanted to peer with VNet-B. And again, a similar questions. Do you want to allow traffic to remote virtual network? Yes. Do you want to allow traffic forwarded from outside the virtual network to be forwarded to you? No. And then finally, we'll leave the virtual network gateway and the route server to none. As you can see here, it is saying that it is actually added two virtual network peering here. So in this case, we see the VNet-A to VNet-B peering under the virtual network A. If we click on VNet-B, we could see that VNet-B to VNet-A peering is here. Next step, we want to configure VNet-B to peer with VNet-C. So we'll go through the same process. We'll pick VNet-C in this case because we want to peer B to C, and then add it. And again, as you can see, we've got two VNet peering being added at the same time. So VNet-B now have two peering. Let's go to VNet-C, and VNet-C has a peering from VNet-C to VNet-B. And with that, let's see if our VMs are able to talk to each other now. Let's go back to home, virtual machines, and let's open up our Cloud Shell. What we'll do here is that we will SSH to virtual machine 1, VM1, and then we'll ping VM2, see if the ping work. And then we will ping from VM1, we'll ping VM3 and see if that works. Okay, so we are now inside of VM1, so let's ping VM2. So let's find out the IP address actually for VM2, the private IP address. So let's ping 10.2.2.4. And as you can see, it's successful. Let's ping the VM3, which is 10.3.3.4. And as you can see here, it is failing because we don't have a VNet peering between VNet-A and VNet-B, sorry, VNet-C. If we jump on VM2, let's see how the traffic is working. So we are now in VM2. VM2 should be able to actually talk to both VM1 and VM3 because VM2 is inside of VNet-B, which is paired with both VNet-A and VNet-C. So let's test that. So we are now pinging VM1. It's 10.1.1.4, which is successful. Let's now ping VM3. Which is again successful. So as you could see, VM1 was not able to talk to VM3, but VM2 was able to talk to both VMs because VM2 is in the middle. It's in the VNet-B, which is paired with both VNet-A and VNet-C. I hope you found this video useful. If you have any comments or questions, please leave them in the comments below. And as always, stay strong. Kia kaha. See ya.